Good afternoon, and thank you for attending the webinar Cat M1 Network for Industrial IoT Deployment, presented by NimbeLink for Sensors Magazine. I'm Matt Durgis, Executive Editor of Sensors Magazine, and I will be your moderator. In today's session, you'll learn Cat M1 capabilities and benefits, its design requirements, and the techniques to accelerate your product development. You'll be hearing from three experts from NimbeLink. First up is Kurt Larson. He is the company's CTO and founder. In addition to holding 3 engineering degrees and an MBA, he has 10+ years of experience in new product development and product management. Next, you'll be hearing from Brandon Hart, NimbeLink's Director of Technical Business Development. Brandon brings 10+ years of wireless industry experience, having worked wide and long with developers and engineers in the development of M2M and IoT solutions. Then you'll hear from Scott Schwalbe, NimbeLink CEO and co-founder. Scott has 15 years executive leadership experience and is responsible for overall company leadership and profitability. Also notable, Scott has contributed many insightful articles to Sensors Magazine on the subject that you'll be hearing about today. Now, just a few notes before we begin. If you have questions during the webinar, please enter them in the space provided on your interface. There'll be a Q&A session at the end in which they will all be addressed. If you have trouble reading a slide, hold and drag the right corner of the slide window to enlarge it. You may also want to temporarily disable your pop-up blocker to participate in the interactive parts of this presentation. Also, if you should experience any difficulties during the webinar, you can message them to us directly via the same interface. So let's begin. Right now, I'll hand the mic over to Kurt Larson.
Hello, everybody. So today on the agenda, we have the what is the Cat M1, the Cat M1 network status, market applications for the Cat M1, Q&A, and this, which is a little different than your normal presentation. We're having the Q&A in the middle of the session so we can cover any technical questions that have arisen, and then kind of finish off the presentation with how people can get moving faster with the M1 network, as well as some updates on and some announcements for the Sensors Expo. For those of you that are new to cellular, the cellular technology has been changing over the years, and many folks have heard about the 2G networks, and some folks have heard about the end of life of some of the 2G technologies in the space. What we're seeing today is that 2G technologies in the GSM and GPRS space in the United States have gone away, and the 3G technologies are currently being reharvested to make up more spectrum available for 4G LTE technologies. And as the LTE landscape has expanded over the years, there's really been two things that have happened. It's been a bifurcation in the strategy of how to support different types of LTE users in the networks. On the high side, to support the handset and mobile space, you have customers wanting to be able to download faster and quicker, and in order to support that, there's been new technologies created with LTE Cat 4, Cat 5, Cat 6, and the 5G technologies, which will be used to continue to support the mobile handset space. To support the lower power networks and longer life battery devices, standards have been created like LTE Cat 1 and the LTE Cat M1, which we're here to talk about today. And the benefits of these are that they are further reducing the costs and lowering the power of the devices so that customers can realize products that have longer battery lives in the marketplace. The two promises of the Cat M1 network is the low power promise and the low cost promise. And in order to do that, in order to make the products have lower power consumption, there's a handful of technologies that have been implemented. One is the PSM, which stands for Power Save Mode. And this allows the device to turn itself off or put itself in a very low power state and not have to communicate back with the cellular network. So this allows the modem to essentially continue to operate, but be in an extremely low power state while it's not communicating with the network. The second is the extended DRX features. The extended DRX features allow the LTE device to only connect to the network in further durations. So a current LTE Cat 3, Cat 4 technology, they're pinging the LTE network about once every second. The extended DRX allows the modem to extend that all the way out to up to 10 seconds. And when you talk about the concept of hyperframes, that can be extended up to 40 minutes worth of off time where it's not communicating with the network. The two things that PSM and EDRX allow the modem to do is reduce the total on-air time while the radios are on. And by reducing that total on-air time, the total product power consumption is reduced. The third and fourth items on this list here is the lower transmit power. So one of the new parts of the Cat M1 standard is that the products no longer have to meet a maximum transmit power of 23 dBm. They can now operate at a maximum of 20 dBm, which that's a linear scale, a logarithmic scale, which means you have almost 100 times lower power in some of the transmit modes that the radios are communicating with the towers in your devices. And the last item here that allows you to get to further lower power states with the M1 promise is the reduced number of packets. And to explain this, the current LTE technologies for Cat 3 and Cat 1, every single packet that is transmitted to the tower is repeated up to 8 times. And the reason they do that is to help extend the coverage into lower signal areas so that every single packet is repeated and the receiving device and the tower can each pick the best of those 8 packets and then build up a full packet out of the 8 that were transmitted. And with the Category M1 technology, your device does not have to acknowledge and listen to all 8 of those packets. So if the device has actually received the data and been able to assemble a proper message out of a single packet, now it can turn the radio off and save its power for the system. So those are some of the enhancements that allow your device to have longer battery life and lower power with the M1 technologies. The second half is the lower cost promise. There's a few different technologies that have come together that have allowed the physical device to be a lower cost point at the silicon level, at the chipset level, at the module level, and even at finished products. And so the first is the RF path. Comparing to an LTE Cat 3 or Cat 1 technology, those devices actually require 2 antenna paths. So you'd have a primary antenna and a diversity antenna to improve the reception and increase the bandwidth from the device to the tower and vice versa. With Cat M1, there's actually a single RF path in the silicon and modules and products. So this allows the silicon vendors and the module vendors to reduce the amount of components on the circuit boards that are involved in the analog front ends and the bandwidth, the bandpass filters that are in those RF paths, as well as for system designers that are attaching the end device antennas to your products. You only have to have a single antenna on the product. So those are 2 major things that allow you to reduce the system level cost. The last is because of the transmissions on the network and the packetization and everything associated with the M1 LTE packets, the complexity of the microcontrollers is lower than what has been required in prior LTE technologies. You don't need to have as high of a processing power capabilities on the actual microcontrollers in the modems themselves. So now you can have a cellular modem chipset with a lower processing capability, and by having a lower processing capability, you can reduce the cost of that microcontroller that's used to drive the cellular radios. So those are the 2 at the highest level, the lower cost and the lower power promise of the Cat M1 networks and how those are realized in the actual devices. Up next here, I'm going to pass it off to Mr. Brandon.
All right. Thanks, Kurt. So as everybody can tell, there are a number of changes that are happening with Category M1. Going from the Category 1 that came before it, going to M1, there's significant differences, not just an additional letter in the name that makes some changes to how the technology is implemented, how it's deployed, and things like that. So what is the status of this technology? It's one thing to have a really cool technology in theory, but it's a whole different thing to have something that you can actually get your hands on, start using, start deploying, and so on. So that's kind of what I wanted to talk through here real quick, just the status of Category M1. So we'll start off talking about the timing of the development of the technology, of the deployment of the technology. We'll get into the hardware and the status of various different levels of hardware, the network deployments, not only here in the United States, but also, as you see in the last bullet there, globally as well. So I know a lot of us are here in the United States, but all around the world, this network is being evaluated and being deployed as well. So we want to make sure we talk about the entire world. So first off, on the timing side of things, so here we sit in 2017 at the beginning of this curve here, this arrow, and this is kind of the year where a lot of this stuff really has started to become real. We had some initial announcements from some of the U.S. carriers at the very, very end of last year. I know there were some successful trials of a real-world network in the end of 2016, but 2017 was really the target for most of the carriers in terms of the kind of the early adopter, leading technology adopters here in the United States specifically for deployments of their M1 networks. And so we're seeing that happen. We're seeing some of the carriers get some proof of concept networks deployed, some testing networks deployed, and in some cases, as the case with Verizon, they've actually gotten their full nationwide deployment of M1 underway as well. So 2017 is a pretty big year when it comes to M1. 2018 is the year that I'll kind of say that M1 becomes a more mainstream technology. As more carriers begin to adopt it, as more hardware is made available for it, and as more device developers are creating IoT devices for the network, 2018 is the year that a lot of things start to change. The M1 technology is no longer this new up-and-coming technology, but actually starts to become fully adopted by the world. And then 2019 is where that full maturation of the M1 technology starts to come into play. So some of the features that Kurt was talking about earlier, the power save mode, extended DRX, you may not have mentioned it, but some of the CE modes, the coverage enhancement modes, things like that are all associated with M1. Those things may not necessarily happen right at network launch. We may see some of those things later on. So as these networks mature, we'll start to see some of those other features and capabilities of M1 be integrated into the networks and into the devices. You have to have support on both sides. So that's kind of the timing that we're seeing, the timing we're expecting going forward for a lot of these networks to be deployed, the devices to be developed to utilize them. But specifically on the radio side of things, where do things stand? Well, the first thing I'll address here is, if you see in the picture, we've got three different categories of hardware. And it's important to understand that there are three different categories of cellular radios, and that the time frames for development on each one affects the one that follows it. So starting with the cellular chipset side, this is the earliest stage. This is kind of the lowest level in terms of cellular radios. The cellular chipsets are developed often a year or years ahead of actual deployment of technology. So the chipset developers have been working on creating the cellular chipsets that support M1 at or even prior, in some cases, to the full finalization of the M1 standard itself. So they've been hard at work getting the chipsets out there so that they can be made available. Once they develop those chipsets, they have to then go through a whole series of testing, of approvals, of certifications with regulatory bodies, PTCRB, GCF, folks like that, as well as carrier certifications where carrier certifications are required. So all of that kind of approval, all of that testing, certification, all has to happen at a chipset level really before it can move on to the next level. That next level is the cellular module level. And so you have a module which typically will add some capabilities, add some hardware, add some software to the cellular chipset in order to make it more useful, add more features, add more functionality. A module manufacturer may add an additional processor. It may add a full operating system inside of a module. They may add a GPS radio. They'll add additional AT commands and features that support, for instance, an onboard network stack, things like that. Then that module, using the previously approved chipset, has to go through its series of testing and approvals and certification in order to obtain the approved module status. So a lot of times you'll see out there that somebody has an approved module. And basically what that means is that they have a module which contains an approved chipset which has gone through the full testing and certification process at the module level. But there's one more level beyond that. That one more level is the end device or end product, or in our case, modem level. And basically what we're talking about here is taking an approved module, which again contains an approved chipset. We take that module, we put it on our device, on our board, and essentially integrate it in to meet the definition of an end device or an end product. And then we go through a whole series of testing, certifications, approvals with PTCRB, GCF, carriers, whatever the relevant testing bodies are for the places or the networks where it's going to be deployed. So there are 3 different levels of cellular radio hardware, and it's important to kind of know the distinction between the two. So in terms of status, the chipsets have been developed for a while now. They're still being finalized. Some of the chipset manufacturers are finishing up the chipset testing, getting their approvals on the chipset level. In the meantime, the module manufacturers are working hand in hand with them, or in some cases are actually the same company, to offer an approved module. So they're taking the modules through the approvals and testing and certification processes. So that's kind of where things stand as of today. Early adopters of this M1 technology, folks like NimbeLink, are working with those chipset and module manufacturers to ensure that the first possible date that there is an approved module, that there is an approved modem, so that customers can begin utilizing the technology. And Scott will talk a little bit more about this later, but essentially you have to make sure that you've got approved chipsets, approved modules, and then you have the ability to use something at an end product, end device level once it obtains certification there. So we're at the last 1 or 2 stages, depending upon how you look at this, for that certification and that approval process on the cellular radio hardware today. Okay, so that's the hardware side. So that's basically saying that there's a car, but we need a road to drive it on. So what about the carriers? What about the networks themselves that are being deployed? Well, you see we've got the big 4 here in the United States listed on this slide. Those are the ones that everybody tends to look at in terms of what's going on in the U.S. but we certainly wouldn't want to neglect everybody else as well. Essentially, you're going to have carriers that are taking different approaches to how they're going to roll this M1 network technology out. You've got kind of the earliest adopters of the technology. Those would be folks like Verizon and AT&T. They are rapidly developing and working with the infrastructure providers to get the technology finalized, get it tested, get it rolled out to the general public as quickly as possible. And then you have others that are taking the more conservative route of allowing the technology to be finalized, allowing it to mature, and then rolling out a fully stabilized version of that technology later on. If you refer back to that earlier timeline slide, you'll see what I'm talking about there. Wait until it matures a little bit more and then roll it out. We see folks from different companies that are taking that approach, and then some are just still kind of to be determined. Some may roll out NB1 instead of M1. Some may roll out NB1 and then M1. So we'll just have to kind of see how some of these other carriers move forward. But the first ones that we have seen network deployments, seen network testing, and are speaking publicly about their rollout are Verizon and AT&T. Again, Verizon has launched their M1 network nationwide. It is a full nationwide network rollout. So the thing to remember is that this is still LTE. It uses the exact same LTE network in terms of the carrier, the cell towers, the eNode Bs that are out there. So your coverage is something that can be immediately turned on and made available throughout the network without having to put up new towers and wait for the network to gradually and steadily grow. It's essentially already there and just has to be enabled for M1. So Verizon has done that. AT&T is planning to do that very, very shortly. Both of them have had test markets up and running for a while now, so we can be reasonably certain that those networks are going to work quite well when they are made available. So that is the current status of carriers in the United States. But what about the rest of the world? Well, we've seen some interesting developments globally with regard to M1. Initially, for those of you who kind of follow the news and statements in this space and the trends in this industry, you may have heard some initial statements from a lot of carriers about how Europe, for example, was going to deploy M1 after they deployed NB1, or narrowband IoT. And that may still happen in certain places, but earlier this year, in February, there was a statement put out that named quite a few carriers around the world, many of whom are in Europe, stating that they are on board with M1. So specifically, that was AT&T, KDDI, KPN, NTT Docomo, Orange, Telefonica, Telstra, Telus, and Verizon all came out and said M1 is the one we're going with, and then NB1 may or may not follow sometime after that. So it's been interesting to kind of see the way things have been changing globally with regard to, will we deploy M1, will we deploy NB1, which one will be first, will we do it immediately, or will we wait till the network technology has been deployed by others so it's more stable. At the moment, it seems like M1 seems to be growing in terms of its favorability with the world's carriers. So we'll have to see how things continue to roll out and mature and determine what the status of NB1 is sometime in the future. But for right now, things are looking pretty good for M1. So that's the status of M1, both here in the United States and also around the world. To take the discussion a little bit further, I'd like to turn it over to Scott Schwalbe. He's going to talk about the applications and use cases for LTE M1.
All right, thanks a lot, Brandon. So what I want to do is get into a little bit of high-level markets, use cases, and then dive into a couple of applications to bring this all together. So if we look at the markets in the industrial Internet of Things space, transportation, logistics, agriculture, environmental, industrial is a broad range, and obviously then smart cities. The one thing that we're going to dive into when I talk about applications is the low power aspect of Cat M, but also I think I want to really highlight that Cat M is a great product for powered applications. So anything that's replacing the 2G network, as we alluded to earlier, the 2G networks are being shut down. 3Gs are being reharvested and reused. So we need an LTE replacement for the 2G technology, and this actually is a great product for that going forward. So we'll talk a little bit back and forth, but then in applications, I'm going to zero in and tie in the coverage and the actual technology into some low power. But if you look at across the board, depending on which market you're in, Cat M1 is a great application for your smart cities, and a lot of you that are looking at technologies are probably hearing about other applications like Sigfox and RPMA, and looking at LoRa technologies, and there's a good placement for all of those. But right now, as we just heard from Brandon, we've got a global network rolled out for Cat M1, coming nationally with Verizon. So anywhere there is LTE, you basically will have Cat M1. So if you're looking at applications like parking or tracking lights, traffic sensors, some of the other things on this list, the Cat M1 is going to be a great application, regardless if it's powered or not powered. Transport and logistics, the other key element, and today we're not intending to get into the narrowband IoT applications, but Cat M1 is a great application for mobile. If the unit is moving from one place to the other, definitely has the capabilities. You'll be able to still take advantage of some of the power save modes. Won't be able to take advantage of everything, but it's still going to be a very low powered power. You won't be power hungry, and then also I think Kurt mentioned, as we look at the packets and the transport, we should be able to reduce the actual data transmissions and reduce some of that cost in these applications also. Same thing with going into your agriculture, asset monitoring, tracking, environmental, depending on which sensors you're building out. If you're currently building out a gateway that has 2G or 3G, or if you're building out some sort of a sensor platform, the Cat M will be a great technology for you to be thinking about deploying that. Brandon mentioned all the global carriers that are coming on board. 6 months ago, probably wouldn't have said this, but it really looks like that Cat M1 is that potential replacement. Now, if we could just get all of them to use the same band, it would be perfect. But so that'll be something that the chipset and the module folks will be working with the carriers to get to a product that can support those global bands. So let's dive deep into a couple applications that we've really been seeing that work very, very well with Cat M1. So if you think about a non-powered asset, something that's, it could be a trailer, it could be a stack of lumber, it could be something that you might have power, but you don't want to take the time to send a service person out to connect the device. The Cat M1 application, it works very, very well for these types of assets. Something that can sit out there, and we've had a recent application as simple as sitting in a device that's not supposed to move. It's an asset that is never supposed to move, and they really want a heartbeat once once a week or once a month, and then when it moves, want to be informed, and then track it until they find it. It'd be a great application for taking advantage of some of the low power states that can happen within Cat M1. Our early testing is showing us that pinging a device and doing a heartbeat once a day could run 7 to 10 years on 4 AA batteries if properly architectured. Telematics, again, a great application. Telematics is a very broad area, but as you look at 2G replacements in some of your solutions, you need to be thinking about how are you going to get national coverage in products that are moving, and in a lot of cases you don't want to power those assets. You want to be able to create an enclosure and with full battery and put it onto your device or onto your asset and track it. Perishables, we obviously we hear a lot about how do we track our food, how do we make sure that our food is not going to spoil. There's millions, if not billions, of dollars of food wasted every year that's being because it's sitting somewhere too long. It's not being tracked. So if you think about multiple sensors being connected to if it's temperature, humidity, it's some of those key temperatures. If it's your environment and you're looking at airflow and pollutants and needing to put something out that's going to sit out in the environment for a lot of years, we're seeing Cat M cellular as a great communication tool back to your cloud, bringing it all back. So could go deeper into a lot of these applications, but what we might want to do now, Matt, is just take a quick a moment here, go to some Q&A, and then making sure that from a technology and from this perspective rollout, and we can leave plenty of time, and then we can dive into a couple other areas of deeper ways to deploy this product.
Okay, sounds good. We got one here. They understand you developed some kind of a hardware system based on the M1 network. Can you give us a little bit about that, please?
Sure. Kurt, do you want to take that one? I think we even have a couple backup slides to talk about that.
Yeah, so I can take that one. So in order to help folks move faster with the M1 network, I think Brandon earlier on in the presentation had covered some of the nuances with the certifications required about chipsets and modules and end devices. To help customers get through those certifications quickly and help customers be able to deploy a product instead of having to go through those certifications, NimbeLink has created the Skywire product line. And the Skywire has already gone through the Verizon certification process for the Cat M1 network, which means customers can buy it today, design it into their products, and not have to go through either the carrier certifications or any more FCC certifications to use the Cat M1 network in the United States. And so that is the main value proposition for the Skywire product line, and is the Cat M1 product that customers can get today to start working with the M1 networks in the United States. A couple things to point out: it is end device certified, which means that, again, there's no more carrier certifications or federal certifications that need to be achieved before you can use the product in the United States. Second, it's also, there's a migration path. So we have a family of Skywire products that cover the 2G technologies, the 3G technologies, the LTE Cat 3, 4, and Cat 1 technologies. So if customers are designing a system that needs to support different usage models, whether it be low power for some applications, and then M1 is appropriate, we have a modem for that market. But then by just changing out the modem, you can move to a higher bandwidth and support higher bandwidth applications, like using a Cat 4 LTE product in that same size and form factor. And then also to make it easy to work with these products, we've created a development kits, and so the development kits are also available now through our distributors. The development kits allow the Skywire modem to be plugged into a baseboard, and that baseboard can then be easily connected to your computer for testing of AT commands and PPP modes and different ways of utilizing the modem. But secondarily, the development kit has an Arduino compatible interface on the bottom side of it, so it can be plugged into a lot of different development kits and microcontrollers that support the Arduino standard expansion board pinout. So that can allow you to take your target microcontroller of choice, get a development kit for it that has the Arduino form factor, plug it into our M1 development kit, and then you can start developing your application very quickly without having to create all of the without having to create a custom circuit board to test out the M1 in your application. And then finally, this builds a little bit more on what Scott was talking about with the application-specific products. We do have a Qtelis platform, which is an asset tracking solution for customers that are in that space where they may not want to create a product, but they actually have some asset that they're trying to track, and they want to deploy something today. We've created an asset tracking device that is a GPS-based sensor that allows you to take advantage of the low-cost, low-power M1 network to get daily or monthly or hourly or even half-hourly GPS location stamps, locations for your asset sent to our platform. And from our platform, we can then send that either to your platform, if you're an OEM that wants to resell an asset tracking solution to your customers, we can forward that data directly to your platform and you can resell that. Or if you're an end user that has lumber, for example, that you want to track, we have a full-blown platform so you can deploy the device, attach it to your lumber, and then have a front-end user interface that allows you to locate those assets throughout your area of wherever they've been lost. So that's the high-level view of the Qtelis. I think the thing to point out and how it relates to M1 is twofold. One is it is going to be the lowest cost hardware that you can get for an asset tracking solution because it's taking advantage of the category M1 network. And second, it also provides a very small footprint because you can have smaller batteries for and still be able to achieve the long battery life that people want in an unpowered asset tracking device. So with 4 AA batteries, getting a device location update once a day, you can have greater than 5 years battery life on that particular device. So those are some of the things that we've prepared to help folks with the Cat M1 network and realizing those capabilities today instead of 12 months from now.
Great. Alejandro Vallejo wants to know, what will be the bandwidth of your initial release?
Good question. So the initial products are on the Verizon cellular network, and right now we're seeing about 150 kbits per second as the maximum throughput, both transmit and receive on that network.
Okay, great. Patrick Dolan would like to know, what kind of subscription will be required for each sensor node to join the Cat M1 network? Would you like me to repeat that?
No, I got the question. I guess I didn't get all. I think there's a few more things that we need to know about that question before we can put together a concise answer.
Okay.
Yeah,
maybe I'll just...
So it's basically, I talked about the carriers earlier that are announcing support for M1, both here in the United States and around the world. And truthfully, it's going to be up to each one of those individual carriers to determine what it's going to take to subscribe to either a certain amount of data, a certain amount of time, or how many devices, etc. So unfortunately, that's one of those questions that we'll have to direct you back to the carriers that you intend to use for your specific M1 deployment in order to be able to get pricing information. We just couldn't represent that here.
Okay, great. Brett Small would like to know what sort of target cost range and battery life is expected for Cat M1 devices.
Yeah, this is Scott. I can jump in. So publicly, you're going to see modules advertised, right now in the $15 range. There's a lot of talk about once they're developed into 2018 and 19, and millions of them are deployed, getting down into the sub $10 range from a module perspective. And then the modems, we're adding value there, so they're that kind of 2 times the cost of the module, and then obviously when people get to finished products, they're going up into pricing, but similar pricing to what you're seeing out there in the marketplace for 2G. Was there 2 parts to that question, or was there just the 1 part?
There were 2 parts. I think it was the battery life and the first part of the question.
Sure, and I think we addressed the battery life a couple different times here, so hopefully we answered it.
Okay, great. Alejandro also asked, when will you achieve 1 megabits per second?
So on this particular product, it will not. So that's not the intent of this particular product. Cat 1 is 10. So if you're looking at something that's looking in that range, you would look at a Cat 1 module chipset versus the Cat M1.
Okay, great.
Yeah, I think it's important to point out with that the carriers don't support that level of throughput yet. So the 150 kbits per second that I mentioned earlier, that's as fast as you can go on the cellular networks that are available today.
Okay, great. Mitch Thompson says, a follow-up to an earlier question. He says, I know you can't provide carrier subscription pricing, but what is your experience so far? He says, is it $5 a month, $40 a year, driven by number of connections or by data volume?
Yeah, this is Scott. I'll jump in, and then Brandon or Kurt, you can jump in. So the one thing to think about is, right now, it's going to be very similar. If you're already using cellular, and you're sending a certain amount of data and data packets, it's really not going to potentially change. But as we're seeing publicly, some of the what we'll call Internet of Things plans are coming out where they're getting a little, doing what I'll call enterprise pricing, where we're seeing it'll be $25 for a gig, and you can tie up to 1,000 units on that. And when you use those, that data, it doesn't really matter if you have 10 units or 1,000 units. It's really around that data. So we're seeing some plans like that. We're seeing plans in the sub $1 for a meg. But as we go forward, we expect to see more of these kind of enterprise where it's not per device. It's a pooled data rate usage. But they're just being currently worked on. But those are the kind of things we're seeing in the marketplace today.
Okay, great. We have time for one more question, but that shouldn't stop anyone from out there from submitting any further questions, which will probably get answered after the webinar. This one comes from Jacob from Hardware Engineer is his name. What features in terms of low power are being enabled on Verizon's network? Is there a roadmap for feature availability?
Sure, so I can jump in on that one.
Go ahead, Brandon.
Sure, thanks. So on the Verizon network, we are seeing some early feature support being turned on, and some of that feature support is being tested and rolled out kind of as we speak. But from what has been communicated so far, we should see some initial versions of CE mode, that coverage enhancement mode. I believe it's mode A, and some power save mode functionality in the initial rollout, with the other features to follow later. Kurt, did you want to add anything to that?
Yeah, I was just going to say, with the nationwide rollout, the PSM features were enabled to the network. The EDRX features are just coming to fruition now in select markets, and the roadmap that's been communicated is end of Q2 timeframe to have nationwide coverage of the EDRX.
Okay, great. So I'll hand the mic back over to you to continue the presentation at this time. And like I said, feel free to still submit questions which can be answered later on, and then in the recorded version will be available on the website within 24 hours.
Sure. Thanks a lot, Matt. Just want to talk a little bit about the upcoming sensor show. We, right now in a short little, 45-minute to an hour presentation, it's really hard to get into the details, answer the questions that most really have the detailed questions. So we've collaborated with the sensor show coming up at the end of June here, and we're going to do a keynote presentation there. But more importantly, we're really going to be driving into an ecosystem discussion. So as I mentioned, we'll have a stage at the event on both days, on the 28th and 29th, and we're pulling in ecosystem partners to really focus and dive deeper into some of the things that we just barely touched on today. So the intent here is not for you to, you can read this if you can see it. It's but really to show that we've started a number of topics that should be of interest for you to deep dive into all aspects of the Cat M. So we're real excited about that collaboration. Wanted to present that to you so you could see that. And when you do get the presentation, there's a code that you can access to get reduced pricing on the conferences going forward. So I think Matt, that was really the end of our presentation. But again, we wanted to leave a couple more minutes for Q&A.
Okay. Let me see what we have here. Brett Small asks, if the transmit power is lower, won't more towers be required to get complete coverage?
So this is Kurt. I'll attempt that one. So the benefit of having the maximum transmit power be lowered is that if you have a device that's close to the tower, it doesn't have to scream as loudly to try and send data from the device up to the tower, which is the highest power consuming part of the problem. There are still advantages of having the higher the higher power for when your device is farther away from the tower so that it can scream louder. The penalty is that you're consuming a lot more power when you're farther away from the towers. So if you always want to live in the I'm only going to transmit at a certain level mode, you're going to have to either live closer to towers, or yes, there would need to be more towers to get the same level of coverage. But the other thing to keep in mind is that these devices are not trying to operate at the same quality of service that a cellular mobile handset operates at. So what that means is when you're on the phone talking to your cell tower, you need to have a higher bandwidth and dedicated resources to keep a fluid audio conversation, both in a duplex mode of talking and listening at the same time. Whereas an embedded device that's out in the field, it doesn't need that dedicated high level quality of service connection. So it can have a very poor connection and still get through the data you're trying to get through at the lower power levels. So it just, you got to keep both ends of the spectrum in context when you're thinking about why it's okay to have lower transmit powers for the embedded devices.
Okay, great. And we got time for one more question. This one's a little bit more involved. It comes again from Alejandro Vallejo. The Cat M1 standard from the 3GPP states that the bandwidth can reach speeds of 1 megabit per second on the high end. Is it that the current plan from the carriers is not to support the high-end numbers for bandwidth, or is it a module limitation, and as they are refined, those speeds might be achievable?
So I'll address that at first, and then I'm going to turn it over to Kurt to maybe add a little bit more technical support to my answer.
Okay, great.
But so basically, there are a couple different ways that M1 can be rolled out. So it can be full duplex, it can be half duplex. The throughput speeds associated with each method of deploying M1 will change, will vary. What we're seeing all of the carriers do that we're working with, that we've talked to up to this point, is they are all deploying the half duplex version, the single antenna half duplex, simplified, lower power, lower throughput version, because that's really what the market is asking for. So the other version that would require, and I apologize, I don't have the names in front of me, but the other version that can achieve the higher throughputs is not the one that is currently being supported by the carriers that we've been in conversation with. Kurt, is there anything you wanted to add to that?
I think the one thing I'll add, which kind of touches on some other questions that have come in the list here, is that the other competing technologies that M1 is going up against in the low power wide area network space, I think the carriers feel that they may not have to reach 1 megabit per second to be competitive. If they're competing against LoRa, they're competing against Sigfox, they're competing against RPMA technologies. Those technologies are so slow, where you're talking about sending bytes at a time, and you're talking about being on air for multiple seconds to get 40 or 50 bytes from a device to a tower. The comparison where M1 is sending 150,000 bytes in less than a second, it's so much faster than what they're trying to compete against in the marketplace that I don't think the carriers have a lot of pressure currently to try to achieve those higher speeds that are stated in the specifications. And so I don't know exactly what's going on, but that is my perception, is that because the carriers are competing against the low power WAN technologies and not trying to compete against other cellular technologies here, there's not a lot of business or market case to try and achieve those higher speeds, so they may never do that.
Great. Well, that concludes today's webinar. I'd like to give special thanks to NimbeLink and the great speakers, Brandon, Kurt, and Scott, as well as our readers and all of the attendees out there. I just want to reiterate that this webinar was recorded and will soon be available on sensorsmag.com website in around 24 hours, they tell me. Once again, thanks to everyone involved, and have a great day.